Hey guys, um, these are the last couple of these here. I might not do all the examples I put in your notes. I just wanted there to be 8 pages, so I put some extra ones. But we'll just see. This one only has 2 terms, which makes it a little different. We saw previously the type 1 and the type 2. This is for trinomials. Trinomial, meaning 3 terms. This one only has 2 terms, but I can see that there is a GCF of 3 in these 2 terms, so I can factor it out. And then this thing in the parentheses is what I have always referred to as a difference of squares. And that has a special factoring pattern, which is you do the first thing minus the second thing, and then the first thing plus the second thing. Let me kind of say that again, because I said first thing, but it looks like it's not the first thing. So, and so to some way of thinking, you rewrite this as x squared minus 1 squared. So these are the things that are being squared here are x and 1. So that's what I mean, the first thing minus the second thing, and the first thing plus the second thing. Another example of that, just so maybe there's another one. I don't know if it would help, but we'll do another example. This is that's one I just am making up because I realized another example might be helpful. If I had like x squared minus 9, that's like x squared minus 3 squared. So you would factor that as x minus 3 times x plus 3. That's what I mean, like the first thing minus the second thing, and the first thing plus the second thing. Okay, that's the factoring. I just wanted to remind you guys of the difference of squares pattern. We're going to see a difference of cubes at some point here, but probably not today. This is a trinomial, and it looks like a type 2 because the coefficient in front of r is not, in front of the squared term is not 1. But I just wanted to point out that this can be simplified a bit by factoring first. When I say factoring, I mean GCF factoring. Like, is there something, do 28, 288, and 80 have a common factor? I'm pretty sure it's 4. I know that goes into 28, and it goes into 4 does. 7 doesn't go into this, and 14 doesn't go into this, so it's got to be 4. So that means you can take a 4 out. I'll leave 7r squared minus 72r plus 20. And now there's no GCFs here. So now I can use the trick I saw before. I say trick. I can use this pattern, the same type of factoring. You see that I'm going to have to leave that 4 on the outside. But I can do the type 2 factoring right here. So I do 7 times 20. That's 140. I'm looking for 2 terms. In this case, because this is positive, I'm looking for 2 factors of 140 that are both negative, because 140 is positive. So again, I need the sum to be equal to 72. So what do we got here? 2 and 70? Oh, that works. That's pretty easy. Let's make them both negative, and I'm good to go. So 7r squared minus 2r minus 70r plus 20. Let me just reiterate, because I know this is an issue sometimes. This negative 72r, I just rewrote in terms of -2 and -70. And now I'm going to group. So I got 7r squared minus 2r. I put the 4 is on the outside. So I want to leave it there. And then now I'm going to point out this other thing I did here. When I factored out a negative, if you notice, this plus became a minus. And this I did because I factored out a negative number. Out. Oh boy. Because I factored a negative number. That means I have to change all the signs. So I factored out this negative. In some sense, it's like a -1 that I factored out. So the negative 70r became regular 70r, and then the positive 20 has to become -20. We'll talk about that more in class if you guys want to. Now, so this was my grouping step. Now I'm going to do my first factoring step. Common to 7r squared and 2r is just r. Common to these two, 70r and 20, I think it's 10. 7r minus 2. And happily, these things match. The 7r minus 2's match. My last step is to take the two things on the outside, r and negative 10. Two things on the inside, 7r and negative 2. So that's the two different kinds of trinomial factoring. If you've already seen this, you're like, you might have a different technique for this, which is totally fine. But if you haven't, or you've forgotten, you can use my way. My way works every time. So it's pretty special. I did want to demonstrate, last thing I'm going to do in this video, so we saw if there's 3 terms, we kind of split it up into 2 types, where A is 1 and where A is not 1. We saw if there's 2 terms, it's often the difference of squares. That's a pretty common one. And if there's 4 terms, we're going to do the grouping that I just showed you. So 4 terms, you want to be thinking about grouping. So it doesn't particularly matter how you group these things. You can just group them whichever order they come in if you want to. So let's just group them the way they are. So I'm going to group n cubed and 7n squared. Then I'm going to group these two, but I'm going to take the negative out first. Minus, if I do minus here, minus 8n. But to get a minus 56, this has to be plus 56 on the inside. It's that same thing where if I do this, I got to change that to a plus. Factor out a negative, you got to make the negatives positive. So I have this now, and I look at what's common in each of these little sets of parentheses I just made. So common to both of these is n squared. I get n plus 7. Common to both of these is an 8. I get n plus 7. That's convenient. And then I factor by the 2 things on the outside, n squared and negative 8. Then the thing that's repeated, n plus 7. And this is done. Sometimes you can factor this one again. There's an n squared. But in this case, it cannot be. N squared minus 8. It's like almost a difference. It's like almost like a difference of squares, except 8 is not a perfect square. So again, so that's how we do these. There's a couple more problems, but they're really the same as the other ones we just did. So I might use those as examples when we get to class or something. If you want to try them on your own, you're welcome to do that. Otherwise, we will work on this more on Friday.